Hi, welcome to my second video on leveling up your Python. And for today's tip, I will say avoid imperative code if it is possible. Now, to understand what imperative code is, let's look at an example. Now, I've prepared here a function which simply calculates the average of a list of numbers. Okay? And inside the documentation of this function, I've listed out some expected outputs that this function should produce. These are doc strings, and if you want to learn more about doc tests, you can look at the links that I'm going to provide below in the description of this video. So for example, this average function, if it takes in integers, a list of integers, it will just produce the average of the list of integers, which may be a floating point number. If you supply it floating point numbers, it will also produce the average. My average function is also flexible in that it can take in complex numbers also, and then the output would be a complex number. Now, also, if let's say we were to pass in an empty list, this not containing anything, the average function just returns 0. So that is the expected behavior of my function, and this is my implementation. And you can see that first we initialize the total, a number, to be 0. Okay? And then using the for loop, I run over the elements in my array and add them to the running total. And finally, once I finish going through my entire list, I would check, okay, is the array empty? If it's not, I will just return back total divided by the number of elements in my array. That's the average. So success, this is what I want my function to do. Otherwise, if the array is empty, I'll just return 0, as this doc test requires me to do so. Now, if I were to run the test, I find that there's no output indicating that this code is working perfectly. So what's the problem? What's the problem with this implementation? Syntactically, programmatically, and mathematically, there's nothing wrong with the implementation of this program. Rather, the implementation problems arise in the issue of understanding what the code is trying to do, and henceforth the maintainability of the code. If people who read your code cannot understand immediately what you're trying to achieve, or have to make an effort to think what is this code trying to do, or follow through the logic of your code, that means your code is not easy to maintain. It becomes harder to understand, and therefore more likely or not to contain hidden bugs. Code should be clear, and in Python there are many functions and utilities which are given to us in order to make our ideas clear, our intentions clear. Now, to illustrate this point, look at this for loop. Sure, for those experienced in programming, one glance and you can see that total basically represents the sum of a list of numbers. But it is actually an effort in thinking about what's happening here, right? You are running through elements in the list and then adding them to the running total. So what does that really mean? Well, after a bit of thinking, you realize that it's actually the sum of a list of numbers. But it's not immediately clear that you are doing that. So one has to figure out what this for loop structure is for and what is it trying to achieve. That is effort, and that is effort which we want to avoid by being very explicit with our code on what this total variable ultimately is supposed to mean. Okay? So let's get rid of perhaps these 4 lines. Alright, we still have a total variable, which is a number, but let's try to write down a line which will really explain to the maintainer of the code what is it that is actually trying to represent, rather than write in such a way to tell the computer what to do, we write in such a way to tell the reader of our code what is it that we intend this program to do. Now, to do that, I have to introduce a function from the Python standard library from the functools package called reduce. So I'm going to import from the functools package a function called reduce. So what does reduce do? Reduce works in the following way. Okay, let's say we are supplied with a list of numbers. What reduce do is that it will take as input, in fact in its first argument, a function, an operation that performs a type of operation on two numbers. So for example, let's say I pass in the addition operation to reduce. What reduce will do is to apply the addition function to the first two entries in the list, in the head of the list, and return back the result to a shortened list. So from the 5-member list just now, reduce applies the addition function which I supplied to it to reduce 1 and 2 become 3. And 3 is put at the top of the list so that it becomes shorter. So now you see this is a 4-element list. And then it iterates through. It applies the addition function one more time to the head of this shortened list and reduces 3 and 3 to 6. Okay, so now you have a 3-member list. Reduce applies the addition function one more time to 6 and 4 and reduces that to 10. And then finally reduce applies the addition function to 10 and 5, which will produce 15 for us. Okay, so that 15 is the final result of the reduction operation. You can see that is something like an iterative aggregation of the elements in the list before you get the final result. So what sort of function can implement this addition operation? We can get that actually from the operator package and import add. Okay, so add is quite simple. It just takes in two inputs and produces their sum. So from total, I'm going to use reduce. So I'm going to pass in, as you can see, a function. This function is actually the add operation which I imported just now. And then I'm going to pass in my array. And then at the same time, I'm going to pass in an initial value which is 0. So my reduction operation starts off with 0 and basically takes in the next element of the list and combines them and then puts them into the head of the list, progressively reducing the size of the list until I reduce back to a single number. Now this is a much clearer statement of our intention. So total basically is a result of reducing the array using addition operations, which actually works out to be the sum, the total of a list of numbers. So this is what we call a functional style of programming. Functional because we pass in functions, which is this add, to another function, which is this reduce. So in this way, our reduction function is actually very flexible. We can customize the operations of this reduction function by maybe passing in another operation, maybe not add but multiply, and then you will get another result. So this is what makes functional programming so flexible and so widely used nowadays. Now this construct here, if else, again logically speaking, nothing wrong with it, but maybe we can improve on the writing of this code by putting everything into a single line. So how is this achieved? Quite simply, we can just return the total divided by the length of the array. So that gives us the average. Only if the length of the array is not equals to 0. So this ensures we're not going to divide by 0. Otherwise, we'll just return 0, okay, as this requires us to do so. So save it and run the test to make sure everything is okay. So it passes. And you can see from previously a 10 odd line piece of code has been reduced to a 2-line piece of code, and it's much easier to read and comprehend what is going on. Now, one last piece of refactoring. This statement here is probably not so nice to look at, and as far as me personally am concerned, I try to avoid having ugly comparison operators like this in my if-else construct. So what we can do actually is to get rid of it and replace it with the built-in function bool, which stands for boolean, and I'll just put in the array. So what bool array does is return true if my array is not empty. If my array has one or more things inside it, bool of array will be true, and so I will then of course return my average. If array is empty, bool of array is actually 0, and then it will just return 0. So then this is a much nicer way to basically simplify your code, so it makes it more economical and nicer to read, and you can check, save it first, that it actually works. So no output means your doc test pass, and which is what you want. Okay, so before we end, maybe it's nice to play around with our average function we have just written just now. So using the Python interactive flag, I can straight away load up my average function and maybe compute the average of 2, 4, and 6, which I should get 4. And if I want to, I can calculate the average of a list of numbers, which I may not be immediately aware what the average is. Okay, so it turns out that it's 3.153. So there you have it, a nice way to refactor code in the functional programming style, and hence avoiding imperative programming in your code. So this is a nice way to have better programming style and make your program easier to understand and much more maintainable. So thank you very much for spending time with me. I hope this will benefit you in your using Python in your daily work. Thank you very much.